Okay, guys, we are just a few days into our chapter over matter, and I just wanted to take a second to review what we started on last week before I begin this next phase, which is classifying matter. So last week we talked about the properties of matter, and we said that matters can be divided into two broad categories, physical and chemical. Physical properties are those that you can measure or observe, and you do not chemically modify the matter by observing that property. Chemical properties do require a chemical reaction to observe and will chemically modify the matter that is present. So these things tend to be more cautionary looking. These are the things that you should feel like are associated with a chemical reaction, because they are. Those are the things that you identify with, like hazard diamonds and that sort of thing. Now, these over here can be further categorized into extensive or intensive. What we learned last week is that there are many more intensive properties than extensive properties. Most of these things over here do not change based on amount. The things that do are these four items right here: the size, the volume, the mass or weight, the potential energy of a substance will change based on amount, and those are extensive physical properties. However, those things that do not change are known as intensive. Now, something that we have been doing the last couple of days in class is actually taking mass and taking volume, taking mass and volume and looking at how those can vary and how we measure those, and then considering how density is actually a ratio of these two things, so it's intensive. Another thing is we were able to take our density measurements and determine that measurements or data that we collect can be either accurate, that is very close to the accepted or true value, or it can be precise, which means that our data is very close within tight range of each other. And so we talked about these two descriptors, accurate data versus precise data. And then we also took a look at how you can actually calculate how accurate you are by using a formula known as percent error. And so we did this with our density cube activity. So we will be looking at percent error, accuracy, and precision and measuring a little bit more later in this unit. Now on to our next topic or category, which is going to be the classifications of matter. Okay, so I really like this table because it shows you what's going on at the particle level. We will be kind of looking at looking at matter from our view, and not from the particle level, but from the worldly view of things as well. So matter can be classified not only into its properties, but its categories. So these are the classifications of matter, how we classify matter. Now, in the last unit, in the Intro to Chemistry unit, we actually looked at pure substances. Pure substances are all particles of matter are identical. So, and there's two forms. It's when you have elements where all the particles are of the same atom type, and then you have compounds where all particles are also identical, but there's more than one atom type present. So it's like a bundle of atoms chemically bound, but still we can see that all particles are identical. So this could be like water, okay, and this could be like the element copper over here, which is Cu, all right? So these are pure substances. Now, when we start combining different types of matter, when we have so over here with mixtures, there is more than one particle type present. Then it is going to be a mixture. All right, so mixtures are when there is more than one particle type present, and you can see that in both of these. Now, we want to talk about how a homogeneous mixture is different from heterogeneous mixture. Now, notice right here that the particles here are not very different from one another, okay? Yeah, this one is made of more than one atom right here, but The point being is that their sizes aren't that different. Like their texture and their composition at the particle level is not very different. So they will blend evenly throughout. And with the naked eye, these type of mixtures look as though only one particle type is present. With the naked eye. Okay, so when we look at these type of substances, this would be things like Windex or air outside or air in the room or contact solution. All right, all of these things appear to be one thing, one fluid particle type, but they're not. At the particle level, there is actually, it's evident there is more than one particle type present, okay? So they are evenly blended throughout, looks the same. That's why we call it homogeneous, because that's what this prefix means. It means same, okay? Now, hetero means different. So these are going to be mixtures where the particle type, the fact that there is more than one particle type present, it's going to be obvious, okay, in heterogeneous mixtures. It's where there is obvious, and I know I already wrote that word, but I want to define this underneath here, obvious particle difference, okay? So it's obvious or evident that there is more than one type of particle in the sample of matter. So this is going to be things like concrete or Chex Mix or like raisin bread. Or it's also going to be things like orange juice with pulp, okay? So orange juice with pulp, or say salad dressing. So like Italian dressing would be another good example. It's where you can see the different particles present. In Italian dressing, all the herbs and spices, they float around when you mix, but like a snow globe, they settle out, okay, eventually. So, and the reason why is because at the particle level, if you'll see here, that these particles have their differences. The ones at the bottom look like they're heavier than the ones that are still floating around, okay? So this would be like sand and water, okay? Sand and water, the sand's going to settle to the bottom because it's too heavy to stay in solution with the water molecule. So sand and water is actually heterogeneous, whereas, say, salt and water is homogeneous because the salt and water molecules are similar enough to where they will stay in solution and evenly blended with one another, okay? So you've got homogeneous mixtures, and a lot of times we call homogeneous mixtures, they are also known as solutions, okay? For heterogeneous mixtures, in terms of like sand and water, we would call this a suspension because the particles actually settle out, just like in, like, say, a snow globe, same sort of thing. All right. So these are your different your classifications of matter, and I'm just going to clear this off so that we can look at it just a very simplistic view once more before we close out the video. But your different types of matter ultimately have to do, is the sample of matter all one particle type? If it is, then it's going to be a pure substance. If it is a particle that is made up of one atom, it's an element. If it's a particle that actually has more than one atom that makes the particle, it's a compound. And then a mixture is either going to be evenly blended throughout and appear to be one phase with the naked eye from the human perspective. And then a heterogeneous mixture, it will be obvious that there are different particles present. We will practice more with classifying matter tomorrow and move into some other things pertaining to matter as well.